Hey everyone, and welcome to Abstract Algebra Lecture 6. Before I do anything else in this lecture, I just want to review some things that we observed in the previous lecture, and I want to add a few things that I probably should have added and just forgot. So let's review some of the things we did last time, or some of the points we made last time. And let me add a few more observations. Given a group G star, where star is an additive operation, we represent A star B as A plus B. And if we have a group that has an additive operation, and we're using the plus notation, if we have a repetitive sum, an element added to itself k times, then we represent this as Ka, k times A. And where it's helpful, we represent the element A as 1A, or 1 times A. We represent the inverse of the element A as negative A. And if we have A plus the inverse of B, A plus negative B, we sometimes denote this as A minus B. So if we see A minus B, what that is A plus the inverse of B, or A star the inverse of B. We represent the inverse of Ka, where Ka is the repetitive sum, A plus A plus A, k times. We represent the inverse of Ka as negative Ka. And in the group Z sub n, with the operation addition modulo n, given that we have a non-zero element A, or an A that is not the identity element, negative A, the inverse of A, is the same as n minus A in this group Z sub n. And remember, Z sub n is the set of remainders modulo n. So Z sub n would be the set of numbers 0, 1, 2, 3, ... n minus 1. Here's a new observation, something I should have mentioned last time. Given a group G star, where star is additive, and therefore we use the plus sign as the additive operation, we often represent the identity as 0. So if we have a group with the additive operation, typically, I won't say always, but typically we represent the identity in a group that has the additive notation as 0. And if G is a finite group, then for every element in G, the order of an element divides or is a factor of the order of a group. Remember last time we concluded with the example of Z6, the remainders modulo 6, and the operation was addition modulo 6. The orders of the elements were 1, 2, 3, and 6. The orders of the various elements turned out to be 1, 2, 3, 6. The orders of all of the elements divided the order of the group, which was 6. And I think we're going to look at this a little bit more closely today before we get into multiplicative notation.